Hi everybody, welcome to the first chemistry experiment we've got for you. In this one we're going to be looking at acid-base indicators. Now for this you'll need the contents of the bag labelled Experiment1, no surprise there, the printed experiment sheet, like this one you can see here, and that needs to be put into a poly pocket as you can see in the image. It's probably easier if you set out the various bottles in line with the appropriate rows and columns on the sheet. The different pH solutions go along the top and the indicators down the side. For the water and the other solutions, I'm using these little plastic shot glasses, which are ideal, but you can use anything waterproof at least. So there's one of these with tap water at the top, and I've also got two others with indicator solutions, as suggested in the instructions. Don't worry if you didn't get around to it, it's not a disaster. This one's got red cabbage juice in, and this one has cranberry juice, just from a carton. And we also have an empty bijou for making up a universal indicator later. Now before we start, a little bit about using the Pasteur pipettes. We've actually given you enough so that you don't need to rinse them, but it is useful to know the appropriate technique. So here I've got a couple of cups for rinsing the pipettes. It's very simple. You take your dirty pipette, squeeze it and suck up clean water from the water cup, and then you squirt it out into your empty waste cup. If you squirt it out into the water, then you'll contaminate that. You just repeat this a couple of times to make sure that it's properly rinsed out. Anyway, on with the experiment. You can put the drops onto the sheet in any order, but I'm going to start with the hydrochloric acid, and I'm going to add 4 drops of acid into each of the circles in the first column. This is cells A1 to F1. The amount doesn't really matter, 4 or 5 is plenty. Next we go on to the pH 4 buffer, and we put 4 drops in each of the circles in the next column. Then the water, then the pH 9.2 buffer, and finally the sodium hydroxide. So now we've got all the pH solutions on the sheet, we're ready to test our indicators. You'll only need 1 or at most 2 drops of each. We'll start off with the bromothymol blue. You can see it's yellow in the acid, blue in the alkali, and the green is in neutral, but that's hidden behind the cup in this footage. Sorry about that. Now the methyl orange. This one's red in acid and yellow in alkali, but you can see that the change of colour happens round about pH 4 this time and not pH 7. It just goes to show that different indicators, as well as going different colours, will also change colour at different pHs. Now the phenolphthalein. This one's colourless in acid, and it starts to change at around pH 9 and becomes bright pink in alkali. Now let's try a couple of the other indicator solutions. In my case, remember, it's red cabbage and cranberry juice. So the red cabbage first. And you can see this one goes red in alkali, and then purple in neutral, and goes on to blue and green in the alkali. Quite a good indicator really. Now the cranberry juice, and you can see that this one is pink in acid and in neutral solutions, and then when it gets into the alkali it goes a sort of dull greenish colour. It still works, although it's not as good. You may well have some others. As I mentioned, tea goes from a sort of yellow to a brown colour, and quite a lot of substances will work as an indicator. Finally, we're going to make our own universal indicator. Students often think that universal indicator is just some sort of a magic super indicator. In fact, it's simply a mixture of different single indicators. So, we take our empty bijou and we add 10 drops of bromothymol blue. And now 5 drops of methyl red. And finally 5 drops of phenolphthalein. You can just use one of the indicator pipettes to stir it and then to add the drops to the sheet. So if you add the drops to the remaining row, you can see this time you get a full range of colour changes from red through to purple. You can use this technique of drops on a sheet for any solutions or reactions that don't need to be heated or don't use solvents that might dissolve the plastic. And it really is quite a lot easier and quicker, and the real advantage of course is the clearing away, because when you're finished you can just take a photo of the results and then wipe it clean with some paper towel.